So I'm going to talk a little bit about AI and robotics foundation models, which are just more extensions of AI, and how we use it at Plus One Robotics. I'm Shaun Edwards. I'm CTO and co-founder here at Plus One. I have about 20 years in robotics and 8 years at Plus One doing robots in the warehouse. But specifically, what do we do at a very high level? We do two things in the warehouse. We do parcel sortation. So if if Amazon sends you a package, that package goes through a distribution system. At every point in that distribution system, the parcels are sorted based on area, based on zip code. That was predominantly a manual operation 8+ years ago. And today we have robots that automate that. We also do palletizing and depalletizing. So lots of materials are shipped on pallets. But believe it or not, pallets are broken down and rebuilt many times in the distribution system. So we sell robots that help build and break down pallets. So first I'm going to talk about problems that we have. So on the bottom left, our robots deal with a lot of brown boxes. Some envelopes, some bags, right? But we also have to handle literally everything else that can be shipped through a fulfillment center or a distribution center. So everything from, dog-shaped boxes, hopefully not dogs, to potatoes, right? Anything that you could ship, our robots will see and have to handle. So what this is it's really a long tail distribution. You can't build a robot to just handle those without handling all of that. So that means the robot has to be able to recognize and handle those items. On the top right, you'll see if you think of packages as varying in size and varying in color or appearance, that changes also over time. So whereas today we're dealing with a lot of brown boxes, around Christmas time, all of a sudden graphics show up all over boxes. And so what you're dealing with today may not be what you deal with, at Christmas time. And so this constantly changes for us. So what does this mean for the robots that are meant to handle those items? All right. So if you look at AI kind of on a spectrum, you have this idea of universal AI, which everybody wants. You want one AI that can recognize any item that may be shipped through a fulfillment center. But if you look at the control over your input and the time you have to actually train and teach that AI what it's about to handle, you'll kind of divide into two regions here. The first is universal, right? So if you have high control over your input and in a little bit of time, you can create a universal AI. These are like AI inspection systems. If you have low control over your input, like we do in distribution, then you need a lot of time to create an AI that can handle all of it. So if you're in the universal area, great, you can create a universal AI. But in the real world, we're actually down in this region, right? Where you have little control and you don't have a lot of time. So this is what we call the adaptable region. And this is the world in which we live in. All right. So another way to look at this is if you have an adaptable AI, then on day one, you're not going to be able to handle 100% of the items that come through your system. But over time, you will adapt to it, right? But again, it's really important that you're productive on day one. All right, if you have an adaptable AI, what does it need to be in order to be useful for a robot in a distribution center? So it needs to be fast. We talked about how these distributions shift, right? New packaging comes out, and now the boxes look totally different. So if you're truly going to adapt to it, you need to adapt to it quickly. It needs to be human light. So a minimum required effort to adapt the AI to new items, right? It can't take weeks or tens of thousands of dollars just to learn a new box that has a new picture on it. And it needs to be somewhat rare, meaning on day one, you need a high level of accuracy to start. It can't be, 10%. It's got to be better than 70% in order to be effective for your customers. We use adaptive AI here at Plus One, but that's only part of it. The real question is, how does it adapt, right? As things change, as the AI needs to learn, what does that process look like? At Plus One, we do something a little bit unique in that we put humans in the loop, right? And so the way this works is you have a non-universal model, and when the AI doesn't know what to do, is confused, it actually sends that information to the cloud, and a person looks at it and says, this is what you're going to pick next. That information goes back to the robot. It continues its job. But in parallel to that, that annotation that they gave us is now used to train the AI model and then create an adaptive model and then replace the model that the robot is using. And that cycle happens over and over and over again. And so that's how we create an adaptive model that is really kind of functional, because on day one, we can get 75% autonomous picks and 25% come through human in the loop. But after 3 weeks, that actually evolves to be mostly autonomous picks. All right, this is a complex slide. So what you're seeing here is basically the accuracy of our AI model as it evolves over time. So if you look at one AI model, the baseline, on the first day that we used it, it had about 70% accuracy. Had we continued to use it, its accuracy would have went down over time, because as time goes on, the packages change. The AI model has never seen them before. It performs worse. So what we do is we create new versions of our AI model, right? These are the adaptations that we're doing. And you can see on the first iteration, we get really high accuracy, right? So very early in a deployment, we can create high accuracy, but it eventually goes down over time as well. But we keep running that iteration. And what you get is, by the time you get to the bottom, after several iterations, you get an AI model that is both generalized in that it works well on all the different data sets that it had to handle, and it's higher accuracy. So that's how these models can adapt. So I put the slide up there because a lot of people ask, hey, why doesn't your AI just learn on its own? And one of the reasons it doesn't is because there are all these exceptions that you don't want your AI learning from, right? Things break open, messes are made. You don't want your robot trying to fix a mess like this. But if your robot just learns on its own, that's exactly what it might do. Back to this flywheel. So with adaptive AI models, what we at Plus One have built is state-of-the-art AI models for parcel handling in the warehouse industry, right? We have over 5 years of data, 1 million picks per day, and 1.4 billion picks in the lifetime of the company. That's more data than almost any competitor that we know of. We have our human in the loop, right? It ensures system uptime by getting the robot that answer very quickly. And it also creates a curated data set that teaches our AI faster because it's only the failure modes that we use for training. And then our production data ensures that, hey, not only we have the best models today, but we will continue to have the best models because they're built on real world data. So everything I've talked to date has been, how do we use AI for vision and recognition? So The next step in AI for robotics is foundation models. If you go to any humanoid robot company around here, they'll talk to you about what foundation models are and why they're important to them. But briefly, they're just models that are trained on a huge data set of robots working in the field. And they basically are end-to-end AI models that control your robots. It's probably what you thought AI was 5 years ago, but it will be at some point in the future if these foundation models actually come out. So at Plus One, we are primarily a vision-based model now, but we are moving in the direction of a foundation model. We're not a humanoid company. So if you think about kind of robotics and capability, there's low-performing robots and high-performance robots, purpose-built and general purpose. Humanoids are somewhere up here, right? They're general purpose, but they're going to be on the low-performing side. Remember, they need foundation models to actually work, right? They're not even here if they don't have an AI foundation model. Here's where we are, right? The different applications that Plus One is interested in: truckload, unload, each picking, mixed depal, palletizing, our induction applications, right? We're purpose-built robots, but we're much higher performing because that's what the warehouse market demands, right? They don't necessarily need general purpose, and they're certainly not willing to give up performance for it. But if we leverage foundation models for us, what does that mean? So basically, everything gets more general purpose and higher performing. So there is value in foundation models for companies even like Plus One, even though we're not a humanoid company. So everything gets better, but also we improve our time to market and we reduce the cost to develop new applications. So it truly is a win-win-win if we can all figure it out. And the last thing I'll say is the person who likely figures out, or the company, it'll be the difference. The difference will be data. And we have been collecting data for a long time. And we have more data than a lot of others in the space. And I believe that's what's going to make the difference for Plus One.